A lot of my students get confused with all these different types of formulas in organic chemistry, so we're going to clear things up once and for all. Now, before I start, I hope you guys know the root name for the different number of carbons. So if something has 1 carbon, for example, it'll be meth something, 2 carbons will be eth something, etc. So these. Now, the easy part is anything lower than 5 because it's the same prefix as the shapes. So pentagon has 5 sides and the hexagon has 6 sides. Octagon has 8 sides and so on. So these are easy. But what you guys have to commit to remembering is the first 4 because these don't give you any, they're not intuitive. They the word meth doesn't tell you anything about it's just 1 carbon. So please put effort into memorizing the first 4 and they actually come up quite often in exams. Okay, now I've listed out all the different types of formulas over here. And we're going to use this one as the example. So what you're seeing here is the displayed formula. Displayed formula means every single bond is shown. So carbon is in group 4, so it needs to form 4 covalent bonds because it needs to share 4 of its electrons to have a full shell, right? So carbon will always have 4 bonds. So you always check that 1, 2, 3, 4 for this carbon, the next one 1, 2, 3, 4, and so on. So you see all of the bonds. Hydrogen always forms 1 bond, and you can see for each hydrogen there's 1 bond. If this is wrong, if the numbers are missing, then your display formula is not correct. Now, this is the display formula. Before I go further, what is the name of this molecule? So you start with how many carbons? There's 4 carbons, right? 4 carbons are going to be bute something. And then you have to know a little bit more about organic chem, which is usually it's alkanes or alkenes because alkanes and alkenes, they are both hydrocarbons. And hydrocarbons have only carbon and hydrogen. So is this an alkane or an alkene? And you guys should know that alkanes are saturated. It means that they only have single bonds. So let me write this down here, okay? So alkanes, in fact, this would help us here, wouldn't it? So the alkanes, they are saturated, which means only single bonds. Only single bonds. Whereas the alkenes means they're unsaturated, and it means it's got double bonds. It can be 1 or more, as long as it's got a double bond. And of course, if it is all single bonds here, then it's saturated. And therefore, it is something ane. And since it's 4 carbons, 1, 2, 3, 4, it will be butane. So this is actually butane. Okay, so that is the display formula of butane. Butane. So this is butane here. Okay, next is the structural formula. What is the structural formula? Now, structural formula is easy. You just need to look at every carbon and then talk about what's connected to them. So the first, I'm going to name these carbons to help you know exactly what we're doing. This is carbon 1, 2, 3, 4, right? So I'm going to write C, the first, this is C1, and what's connected to it? There is 1 hydrogen, 2 hydrogen, and 3 hydrogen. So it's CH3. So that's C1 done. Then you move on to C2. C2, what's connected to it? 1 hydrogen, 2 hydrogen. So it's CH2. And then move on to the next one, C3, also 2 hydrogens connected to it. So that's also CH2. And then the last carbon, which is 1, 2, 3, CH3. So that is what a structural formula is. You're just writing it out, but you have to show me what's connected to every single carbon. Molecular formula is the total number of carbons and the total number of hydrogens. So you just count them. So how many carbons are there? 1, 2, 3, 4, right? 4 carbons. And how many hydrogens? You count them. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is C4H10. Empirical formula is the simplest ratio. Simplest ratio means you try to simplify it to as much as you can. So how can I divide them to make it the smallest? I can divide by 2. That's the biggest number I can think of that I can divide by. That would give me still integers, right? Full, like whole numbers. So C4, 4 divided by 2 is 2. And H10, 10 divided by 2 is 5. And I cannot simplify this further, isn't it? I cannot make it even any smaller without going into decimals. So therefore, this is C2H5. That's the empirical formula. And then finally, for general formula at IGCSE, you just need to know the general formula for alkanes and alkenes. And this one is an alkane because it's saturated, as we just said. So alkanes, the general formula is CnH2n plus 2. And alkenes is CnH2n. And you can actually check that. We have here, what do we have? We have this one, C4H10. It should correspond to the general formula of an alkane. So here, N is 4. So what is 2 times 4 plus 2? 2 times 4 is 8, plus 2 is 10. That's why it is C4H10. So these are all of the different types of formulas using butane as an example. So now that we have gone through all the different types of formulas using butane as an example, let's now speed run through all of these organic chem molecules down here and try to do as much as we can. So starting with V. For V, the name, when you name something, you do two things. Number one, how many carbons does it have? Because that tells you, is it meth or eth and prop and so on. The second question is an alkane or an alkene? So for V, I'm just seeing single bonds, right? So therefore it's an alkane. And since there's 8 carbons, I've counted them, that will be octane. Octane, nice and simple. Next is the structural formula. Structural formula, I'm just going to go through all of the carbons. So the first one is CH3, the second one is CH2, 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 CH2. How many do I have? 1, 2, 3, 4, 5, 6, 7. And the last one is CH3. Done. Molecular formula, I'm just pooling all of the carbons together. So total carbon is 8, and total hydrogen, since it is an alkane, it should have a general formula of CnH2n plus 2. And since n is 8, then 2n plus 2 is 2 times 8 plus 2. That will be 18. And if you count the hydrogens, you will count 18 hydrogens. Next is empirical formula. You just simplify to the simplest ratio possible. And I'm going to divide everything by 2 here. That gives me C4H9. And that's as simple as it can go. Last one is general formula. This is an alkane, so therefore it is CnH2n plus 2. Wasn't that easy? Okay, next one is W. For W here, how many carbons do I have? 2 questions, right? What group and what carbon? So 4 carbons, that's a bute. And then I'm just seeing single bonds, so that's got to be saturated. It's got to be an alkane. But it's not butane because it's actually a circle. It's a circular. So we actually call it a cyclobutane. Okay, next, the structural formula, that is just every single carbon, CH2, 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 and CH2. Next is the molecular formula, pool everything together, C4H8. The empirical formula is the simplest ratio. I divide everything by 4, that gives me CH2. And then finally, general formula. General formula for cycloalkanes, you do not need to know at GCSE level. Okay, moving on to X. X here, same thing, let's name it. How many carbons? 1, 2, 3, 4. So that's a bute. And then what group is it in? It's not an alkane or alkenes because there's an oxygen here. For the triple people, you know this is an alcohol. So this would be a butanol. Okay, next is the structural formula. I love doing structural formula for alcohols. So the CH3, CH2, CH2, CH2OH, right? CH3, CH2, CH2, have I done all of it yet? CH3, CH2, CH2, one more CH2OH. Next is molecular formula. Just pull everything together. So total how many carbons? 1, 2, 3, 4, 4. Total how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there is one oxygen. And then the empirical formula is exactly the same as the molecular formula because the oxygen is already 1, so you cannot simplify it further. And finally, for general formula, alcohols, you do not need to know for GCSE or IGCSE. Moving on to Y. Y here is, you're getting really used to this now, right? To count the carbons and then what group is it from. So 4 carbons as bute, it has a double bond. So definitely it's an alkene, isn't it? Because it's unsaturated. Therefore, it will be butene. Butene. Okay. Then, structural formula. Let's go through every single carbon. I have, the first one is CH2, and then it's CH, and then CH2, and then CH3. Next is the molecular formula. Let's pull everything together. How many carbons do I got? 4 carbons, C4. How many hydrogens? 1, 2, 3, 4. Should be 8. Why do I know that so quickly? Because it's CnH2n. So it's just double the number. Hydrogen is double the number of carbons because it's an alkene. Oh, and I haven't done the empirical formula. Empirical formula, try to simplify this as much as you can. So that would be CH2. And good news, guys, we don't have to do Z because Z is the same as this one. So we are done. Now, there's one more point I want to make, because sometimes they ask us on past papers, is just take a look at Y and W. What you notice about them is, what do they have the same? What do they have the same of? They actually have the same empirical formula, isn't it? But they're completely different groups. This is a cycloalkane. This one is an alkene. But this is why they sometimes ask, they're like, oh, what's special about W and Y? Is that even though they're completely different groups, one is an cycloalkane, the other one is an alkene, however, they actually have the same empirical formula. And that's because this is a circular alkane, so you actually have 2 less hydrogens, so it ends up being a CnH2n as well. So actually, the general formula for cyclobutane is the same as the general formula for alkenes. And that's it.